So speaking of getting data from a database, so it looks like InstantDB, you also have to like design your schema structure. In some ways, this is similar to like Prisma or a bunch of other like data
hmm
layers that people might have been familiar with. So can you talk a little bit about like the schema design and sort of like what that looks like?
Yeah. So there's kind of two things we wanted to do with schema and some kind of other inspirations. So I'll share them. One of the things we wanted to do is we wanted to make it easy. So when you start out, you shouldn't have to define a schema. If you want to, you could, but it should be possible to not define it. I think this kind of goes against the grain sometimes, but I do think it's important because sometimes you really do want to move quickly. And the difference between 1 day and 2 days means that, you have the time to build a project or you don't have the time. So we wanted to make that initial experience really easy. But as your app grows, you need to have relations, you need to have constraints, right? So what the way Instant works is you define you can start writing code, you can start saving data, and we'll kind of automatically create tables for you. But once you're ready, you can set up a schema, and under the hood, the schema works kind of like a graph database. And this is kind of esoteric, but it's also interesting. The place where we got this idea was from Facebook, where under the hood, Facebook runs on a graph database. And why is that important? Because most of the time when you're writing front end, the kind of queries you want to write are not the traditional SQL queries. They're actually queries with a lot of joins. So, for example, just to load a page like a task manager page, you would get the teams. For the teams, you would get the tasks. For the tasks, you would get the author. For the task, you get the comment. For the comment, you get the author. Right? So there's this giant kind of query that you need to write. And sometimes writing that is a lot more idiomatic in a graph structure. So under the hood, um, Instant runs. So in order to make both of these things work, we need to support relations. We want to make it super easy for you to start building without a very strict schema. We run it on top of a graph database.
So with these like distributed systems, there come a lot of different problems that you have to deal with. Uh,
hmm
and in that, you have to balance two things: the instant optimistic updates, where the UI
hmm
shows to the user instantly what happened, and then eventual consistency of relating that to what actually happened in the back end. So how do you like balance those two, and what is Instant's approach to that?
Yeah, I would say there's a lot of pragmatism here too. When we first started working on this, a lot of the initial thought was we need to solve CRDTs to really like make this work. But turns out the surprise is that if you look at how Linear works or Notion or Figma, they just use last write wins, which theoretically is a CRDT, but I feel like that stretches the definition a little in terms of difficulty. So the way that we kind of do things is like this. First, there's a pragmatic approach where by default, the way conflict resolution works is at the attribute level. So what that means is if you have, let's say, a Figma layer and you change the font color and somebody else changes the font size, that is not going to conflict. But if both people change the font color, that is going to conflict. Now, the way that it by default works is like this. When a user, let's say, changes the font color, in the front end, we keep two different states. We keep a queue of all of the transactions that the user has made, which the server has not kind of integrated into the query. So we say, this is from the perspective of the user, this is the latest value, right? Then if any change happens, which happened before this transaction, we kind of write it on top of that change. So from the user's perspective, they're always seeing the change that they made. Now, eventually that change will come back through the system, and then it will remove that transaction from the queue, and then they'll get into a basic state again. And for like the majority of cases, this kind of solves the problem. But in cases where you have more issues about consistency, I think this is something that, I think platforms can try to solve this, but really this is a business domain. Like you need to know how you want a conflict to resolve. So there's a lot of talk, like for example, CRDTs can help you resolve conflicts, but in effect, they don't fully because sometimes, it'll reach to a convergent solution, but it actually is not the convergence that you desire. And you can tweak things so that it converges that way. But oftentimes, I think the 80-20 approach that works for linear Figma and Notion is make it last right wins for almost everything, right? And then in cases where you care, you can kind of funnel the data through one place and then make a decision on what should happen in that case.
I think a topic that'll tie in nicely to
Mhm.
both the question before and this one. Just reading through the site, so Instant is actually built on a triple store. There's this database in the Clojure world called Atomic, which is where I learned about triple stores to begin with, I think. So I'm assuming that that's the basis of the graph database. Could you give like a high level overview of like this data model and kind of how it works and how it might be different than users are used to? And I guess to add on to that, if there's anything about the triple store that enables the sort of sync that you just talked about, that'd be interesting to hear more about too.
For sure. It's a very interesting question. So let's first kind of take a step back. I think the way you can discover the triple store paradigm is like this. Imagine you're trying to build a database and you want to support relations, right? You want to be able to say users can have posts, posts can have comments, and you want that to be fast. Eventually, you'd also like to have strings should be strings and numbers should be numbers, things like that. But that's your kind of constraint. Now, you could try to solve this problem in multiple ways. You could try to solve this problem by basically implementing the entire SQL system, right? But the problem with that is the language of SQL itself is very, very large. I think if you start out trying to create a database that competes with Postgres, for example, that's going to be a painful thing because 25 years of excellent research goes into it. But now, what a triple store can do is, if you think about the most simple way to express relations, you could say it's just, you could imagine instead of having a bunch of tables, you have one table, and you say for a row, you can explode it out and you say, for example, user ID 1, name, Andrew, right? User ID 1, favorite color, blue, right? And then to have a relationship, you can say user ID 1, podcast, devtools-fm, and then, and suddenly now you have this relationship, right? This model originates from like RDF data stores and all these things where it's a very nice way to explain like facts of information that aggregate together. The nice thing about it, I think, like, why is this so useful, is it allows basically three things for us. One is, I mentioned on the client, you need to run queries locally, right? For it to work offline and to get optimistic updates. Now, if we wanted to run SQL queries locally, we would have to use something like SQLite, which is a very large binary to add into anybody's website. So the benefit of this kind of triple store approach is you can write a query engine on top of that in about 100 lines of JavaScript. Now, it's obviously not going to be efficient, but also you can make it very, very efficient. Like there is literature on this. So the first thing that the triple store helps in is that suddenly now you can write client-side databases in a very, very small amount of code. The second benefit that it does is triples are naturally good at this conflict resolution we talked about. Because, for example, Andrew, favorite color, blue, Andrew, hair color, black, they're separate rows in the database, so they don't conflict with each other, right? And then there's a final advantage, which is what we wanted to do was we wanted to make it so that you could truly have a free tier. So, a user can sign up an instant. We can spin up a database in theoretically like 5 milliseconds. But when I say spin up a database, all we do is create a logical row in this single database that kind of partitions data. And the benefit of that is now every user can have a truly free database that never pauses. Because we can also write this kind of query engine on top of something like Postgres and get the benefits from there.